So today we're going to take a look at chapter 2. Okay, we're going to try to get through as much as we can. A lot of review concepts again. This is the last time we're going to really go through a lot of stuff quickly. After this, we're going to slow down. We're going to do one section a day, much slower than we're going right now. Okay, so I'm going to skip over that. First thing we're going to talk about is looking at whether a number is less than another number or greater than another number. Okay? And we're going to do it by visualizing it on a number line. Okay? If you think of a number line, the bigger numbers go in which direction? To the right or to the left? Which way? Clayton? To the right. That's exactly it. So on a number line, if one number is to the right of another, then it's bigger. What if it's not to the right? What if it's to the left?
Smaller.
It's smaller. Okay? So that's how we can use a number line to think about it. Right? Everyone understand that idea? Okay? If a number is to the right of another number, it's larger. If it's to the left, it's smaller. Now it might seem pretty easy, but some people start getting confused when I give you numbers like negative 5.3 and negative 5.4. Which one is bigger? So we're going to do that example in a minute. And I'm going to have you just think about it on a number line. Okay? That's how we'll do it. Okay, any question on that? Pretty straightforward? Okay.
Yes, sir.
So let's look at some examples. I'll start with that one. Negative 5 and negative 2. Okay, so if you get confused, think about it. Think about it on a number line. Think of which number is to the right. That's the bigger one. Okay? And you're either going to fill in less than or greater than. Give everyone a minute to think about it. Yeah, Matt, you think you know?
Negative 2.
Okay, so negative 5 is...
5 is less than negative 2.
Does everybody agree? Yeah. Okay, if you were to draw that out, negative 5 would be right about there. Right? Negative 2 would be right about there. Okay, since negative 5 is to the left of negative 2, it's less than. It is smaller than negative 2.
Guys, which number is closer to 0? Negative 2. When you're dealing with negatives, the closer the number is to 0, the greater value it has. It's like the opposite, because the further away you go from 0 on the positive side, the more value it has. So it's just the opposite on the other side of 0. That's all.
Question on that?
Yeah, why is the arrow facing that way?
Okay, so we just said if a number is to the left of another number, what does that mean?
It's less than.
Or smaller.
Yeah.
Exactly. That's why we put a less than.
Okay.
That symbol is less than.
Think of that thing, think of it like Pac-Man, right? Listen, Pac-Man always wants to eat the bigger number. He's got a big appetite, so he wants to eat the bigger number every time.
Okay.
See how it's kind of going towards him, like chomping at negative 2?
Yep.
It's hungry, it wants to eat more. I know. That's all I remember.
This could be an alligator.
Okay, how about that one? 4.5 and negative 6. So is 4.5 greater than negative 6, or is 4.5 less than negative 6? Say on.
4.5.
Is it greater than negative 6 or less? Yeah, it's greater. Right? Just like Mr. Roy said, bigger number. It's always Pac-Man trying to eat the bigger number, right? Okay. Well, here's a tricky one. These are close. Negative 5.3 and negative 5.4. Which symbol are we going to use? If you get stuck, think of it on a number line. Think of which one would be. Looks like most people are getting it. Austin.
Negative 5.3 is greater.
Yeah. Exactly what Mr. Roy said. This number is closer to 0, right? Negative 5.3. It's to the right. Okay. Any question? That's a tricky one. What if the negatives weren't there? What if it was like this? Does that change anything?
Yes. Yeah. The 5.4 was greater.
Now the 5.4 is greater. Okay, so those negatives make a big difference. They make a big difference. Okay?
What if it was the same number?
If it's the same number, then we would use equals. Okay, for these problems, we just pick less than or greater than. Okay, numbers are opposites. Okay, if you know this idea, you don't have to write this down. I just want you to understand it. Numbers are opposites. Basically, if you look at them on a number line, and they're each the same distance from 0. Okay? So like if you had the number 5. What's another number that's on the other side of 0, still 5 units away from 0, but it's 5 units on the other side? Yeah, negative 5. Okay, 5 and negative 5, those are an example of opposites. Okay, really basic idea. Any question on that? Okay. Okay, if you have a number and you want to make it its opposite, you just put a negative, you just put a dash in front of it. That's how you take a number and make it its opposite. So what if I already had a number with a dash in front of it?
Put it without a dash.
Yeah, right? If you already have a number that's a negative, its opposite has to be a positive. Okay? So that's the idea of opposites. Okay, any question on that? All right. So what would happen? What about this one? Okay, it says the opposite of negative a half. That's one way to read it. Or negative a half. Because this is going to happen when you do subtraction. Sometimes you're going to get negative, a minus. What happens? Let's see, somebody else. Marcus.
When did it become a positive?
Positive
Half.
half. Okay, so when you have two minuses in a row right next to it, right in front of it, they cancel each other out. All right? How about that one? What's the opposite of 0? 0. Okay? If you take the opposite of 0, it's 0. 0 is the only number that's its own opposite. It doesn't change. Negative 0 is the same as 0. Okay? Any question on that? All right. Absolute value. How many people have seen that before? Absolute value. Okay? Absolute value, basically, what it does is it measures how far away a number is from 0. That's it. How far away a number is from 0.
Guys, the biggest thing about absolute value, you can do it in 3 words. Distance, no. That's the biggest thing for absolute value, the distance from 0. It's like we talked about in a couple slides prior to this. That's all it is, the distance from 0.
So, as Mr. Roy just said, since it's a distance, what kind of number does that mean? Anytime you have a distance, what kind of number does distance have to be?
You only have 2 choices.
Think about like if I measure the length of this table, I'm going to get, Mr. Roy said there's 2 choices. If it's a distance, okay? Well, those are the choices. So, when we're talking about distance, can distance be negative?
What kind of number does it have to be?
Say, Mom?
Distance can't be negative.
Distance can't be negative, so it has to be positive. Okay? That's the idea with absolute value. Okay? It's always positive. Okay? How about the symbol? Anybody remember what the symbol looks like? What we draw to show absolute value? Sam? What kind of lines? Yeah, up and down.
Whoa,
There we go.
They're throwing like geometry into this, man.
The parallel lines.
Parallel lines, I love it.
Exactly. Okay, you just take two lines, you put them just like that. That's the symbol for absolute value. Okay? So let's try an example. So, what is the absolute value of 7? Okay, since Sam gave us our definition, we'll let you go. Do the first one. Go ahead. What is it? 7. No, the absolute value of 7 is 7. Okay. How about the absolute value of negative 2.3? Let's try someone else. How about Justin? What's the absolute value of negative 2.3? 2.3. Right? How about 0? The absolute value of 0. How far away is 0 from 0? What's the distance from 0 of 0? It's a tricky one. Victoria? 0. Absolute value of 0 is 0. Okay? Any question on that? You guys ready for a tricky one?
Yep.
Can you handle a tricky one? Okay. Now let's just read this one first. Okay, this one says the opposite of the absolute value of negative 4. Okay? So first thing you want to do is just think of what's the absolute value of negative 4. Okay? And then we'll deal with that negative in a second. All right, so let's try this one. It's a little tricky. The opposite of the absolute value of negative 4. Okay? Let's just start with what's the absolute value of negative 4? A couple people I heard say it. 4. Okay? Now, it's saying what's the opposite of the absolute value? Exactly. Okay? So some people say, well, wait a minute, I thought absolute value was always positive. It is. What happened is you had an extra negative out in front. This negative right here, is that inside absolute value? What do you think? No. That negative is in front. So that negative is not going to disappear. Okay? All right. Let's try one. We'll try one more. So this one's a little bit of arithmetic. The absolute value of negative 8 plus the absolute value of negative 5. Okay, what you want to do is just do it one step at a time. Just first tell me what the absolute value of negative 8 is. That's all I need to know. 8 plus 5. Now that we did that, now we add them up.
13.
8 plus 5 is 13. Okay, you guys are good. Okay, you got it? Yeah, we could do some other one, but that's the basic idea. Skip that. Okay, so now what we're going to get into is some basic arithmetic. Okay, these skills we're going to show you right now are very important. Mr. Roy is going to put some of the rules up right on the left-hand side of the board for us. Okay, but adding, subtracting, multiplying, and dividing with positives and negatives. That's all year. All year you need to know how to add, subtract, multiply, and divide numbers. Okay? So we're going to go through some really, really basic examples to start with. On the board I wrote down some important pages. Okay? If you don't have a chance to copy down all the rules we're putting on the board, they can all be found in your book on these different pages. But we're going to try to put the important rules up here for you. Okay? So make sure you copy down whatever Mr. Roy writes.
So guys, yeah, on your reference sheet, you're going to want to have this, all right? Because again, a lot of times people think, yeah, I know the rules for adding and subtracting positives and negatives. Then you make that simple mistake that it's no good to you, right? All right, what did we say yesterday about the signs? Sign to the, what side? Sign to the left, right?
All right, so what Mr. Roy's writing down, we're going to look at, that's our first example. We're adding two numbers with the same sign. Okay, when you're adding numbers up, you can kind of break it down into two categories. Are you adding numbers together that have the same sign, in which case we do something, or are you adding numbers together that have different signs? Okay? We're adding numbers here that have the same sign. Okay, using the rule that's right on the board, what's the sign of each of these numbers? They're both what kind of number? Yeah, they're both negative. You're adding negative numbers. Okay. Does anybody know what the rule is to add two numbers that are both negative? It's actually a very similar rule to add two numbers that are both positive. Okay?
Negative plus negative equals negative.
Yeah, when you add two negatives, you get a negative. Okay, so the idea, when you add numbers with the same sign, all you do is add the numbers up and use the sign that was in the problem. So we're adding negatives, we're going to get a negative. And then we're going to do 12 plus 19, which is how much? It's 12 plus 19.
31.
31. And that's it. Yep. So when we're adding two numbers with the same sign, add them together, and then put the sign in front of the types of numbers you were adding. Okay?
You know, like Mr. Hager said, guys, we got two categories. We just did the same sign. So all I'm gonna do is keep the sign, add the numbers together. Again, like Mr. Hager just did, put the sign first. Write the sign down first, so you don't forget to put it. Put the sign down first, add them together. That's all you gotta do. All right, I'll give you guys, before Mr. Hager goes to that next one, give you guys a chance to write this down. Guys, you're gonna want to, put this on your reference sheet.
Okay? So using the rule that Mr. Roy just wrote, what would happen if you add a positive to a positive? What kind of number are you going to get? A positive. Okay? If you add positive to positive, you get more positive. If you add negative to negative, it gets more negative. Okay? Any questions on adding numbers up with the same sign? Okay, you guys have been doing this a long time, so we're not going to spend forever. We're going to go right to the next type, which is adding numbers with different signs. Still only two numbers, so we don't have to worry about PEMDAS yet. But we're adding numbers with different signs. Anybody know how you do that? And we're going to, well, you tell me. Go ahead. Somebody tell me what you think we do. Let's see. How about Joe?
You add them together, but you subtract the negative part.
So you want to add them or you want to subtract them? One of those two things you're going to do.
The way you cut, subtract them.
Yeah, you do subtract them. Which way do you do it?
16 minus 12.
Yes, you subtract them. Larger minus smaller. Okay, you subtract them. Larger minus smaller, and then
You should get a negative.
you should get a negative. So the way we say it is you take the sign of the larger number. Okay, so this one's a little bit more tricky. When you add numbers with opposite signs, you end up subtracting larger minus smaller. And then you take the sign of whichever number is larger. Okay, look at 16, look at 12. Which one's larger? 16 is larger. What's the sign in front of 16? Negative. That's how we know this is going to be a negative. Okay, so I like to write it down right away. Okay, now what is it? What is 16 take away 12? Yep, 4, and then take the sign of the larger number. Okay, any question on that? Okay, so we'll give you guys a second to copy that rule. Okay, how about this one? Okay, it's 3 plus negative 2 plus 4 plus negative 6.
Guys, take a second. Try that one on your own. Let's take a second.
I think that's too hard.
Good. All right, guys. On this side, right? I don't want to know your answer. All right, but I want to know on this side is this number when I do those two things positive or negative, Spencer?
Positive,
Why?
because the larger number is positive.
Yeah, large number is positive, right? So what you get?
1.
1. 3 minus 2 gives me 1. Leave my plus sign in the middle. Sam, on the other side, is your answer going to be positive or negative? Why? 6 is bigger than 4, right? Back where I come from it is. All right, so what I do sometimes is I just read it backwards. So I know my answer is going to be negative, right? 6 minus 4 gives you what? 2. Last part, right? I got a negative 2. I got a positive 1. Answer is going to be what? Positive or negative?
Negative.
Negative, because 2 is bigger than 1. Dom, what do you got?
Negative 1.
-1. Beautiful. Again, so it's like a whole bunch of numbers, but as soon as I put those little brackets around them, everybody's like, whoa, okay, now it makes sense. All right, so if you need to do that, do that. Okay? Oh, Mr. Hayes. anal about that stuff. I want to make sure it's back in the right spot.
Now, notice here, we had all addition, okay? Remember what we said about addition? You can change the order you do it in. So by Mr. Roy adding in those grouping symbols, that was okay. But if we had some subtraction signs in here, like 3 minus -2, minus 4, minus -6, we'd have to be careful about how we group it. Okay? So when we start mixing addition and subtraction, you always do it left to right. You can't add in your own grouping symbols and decide, I'm going to do that first. Okay? With addition, it's okay though, because addition is commutative. Okay? So like if you had something like 3 minus 2 plus 4. Right? I cannot add grouping symbols like that. It's going to give me a different answer than the original problem. All right? Because of that minus sign.
Guys, if you were gonna do that, like I told you guys earlier, take that. We know that negative sign in that example Mr. Hager just put goes with the -2. So if you were gonna put grouping symbols, put the grouping symbols in front of the negative, because the sign to the left always goes with that number.
Yeah, it's a good point. Everyone understand what Mr. Roy just said?
Yes, sir.
Good? Okay. That's important. Okay, evaluate. What does evaluate mean? We talked about that yesterday. Plug in. Exactly. Plug in. How do we know what to plug in? Right, they tell you. Okay, they tell you what to use for X, and they tell you what to use for Y. Okay? What are we going to use for X in this case? Yeah, we're going to put a 5 right there. What about for Y? -8. We're going to plug that in right there. Okay? And what are we doing with X and Y? What operation? We're adding. Okay, we're adding them up. We have 5 plus -8. Why do I put that -8 in parentheses? There's a reason why I did that.
Yeah, no, it's all.
So,
Yeah, go ahead, Tyler.
Plus and minus sign put together.
Right. Okay, if you don't put that -8 in parentheses, what's going to happen is it's going to look like this. 5 plus minus 8. Okay, that's going to look confusing. So that's why when we substitute in for X or Y, we put it in parentheses. Okay?
I know, it's hilarious.
So now what do we get when we do that? 5 plus -8. We're adding numbers with different signs. Clayton? -3. Okay. Remember, if you get confused, okay, think of it as doing 8 minus 5, which is 3, and then take the sign of the number that's larger, okay, which is the 8. And that had a negative. Okay? Any question on that? Okay, so that's a little bit of addition, the rules we just showed you, this time combining it with evaluate. Okay? Now we're going to try some subtraction. Okay, we're going to try subtraction. Okay, if you look in your book, they have rules for how to do it. They basically tell you to change it to an addition problem. Sometimes people get more confused with that. All right, so if you have a way that you do subtraction and it works and you understand it, I would stick with the way that you know. Okay, but let's just try a couple of them.
When I'm trying those like first 3 on them, Mr. Hager,
I think we have 3, yeah, maybe.
bust them all up.
Want to see them all?
It's not a lot.
Yeah, guys, I think you guys want to do this stuff, rather than Mr. Hager and I doing every single one, take some time, do those 4. We'll come around, we'll double check, make sure you guys are on the right track.
What happens when you do 2 minus 5? You have 2 take away 5. Think about what's going to happen.
oh, I got this.
Spencer?
-3?
Yeah, -3.
No, I'm not good. Negative?
Sure, because if you have 2 things and I take 5 away from you, I'm taking away more than you have.
Yeah.
Okay, anytime you take away more than you have, that's negative. Okay? Now, Mr. Roy mentioned something. What happens when you have minus a minus? We did this earlier, like the becomes addition. So what does this problem become? Addition. 6 plus 9, which gives us how much?
15.
15.
No, I had that.
Okay, how about the last one, C? Is anything going to happen there that we saw earlier? So how can we simplify this a little bit? What happens? What's going to happen? Chelsea.
You're gonna add the opposite. You're gonna add turn the negative into addition.
Which negatives are going to turn into addition? Not all of them, right?
Yeah, that one,
This one, yeah?
and then the others.
Yeah, these two together are going to cancel out. It's going to become addition. So it's becomes negative 2.3 plus 1.8, which is how much? Matt?
Negative
Negative,
4.1.
um,
Or am I going the wrong way?
remember when you add numbers with opposite sides, you subtract them, and then you take the sign of the larger number. So what do we know the sign is going to be right away? Negative.
It's definitely.
And now if you subtract 1.8 from 2.3, what do you get? Point what?
1.5. Wait,
Point five?
0.5.
Oh, wow.
I was off by,
Okay, negative 0.5. Negative 0.5.
that's
All right, so this one says, it's like a word problem. Okay, the temperature rose from negative 3 to 16 degrees. They want to know how much did the temperature change? What operation in math do you use to find the change between two numbers? Like if you had, a 70 and then you went to a 90, how do you find the change between the two? Do you add, subtract, multiply, or divide? Savon?
I think it's addition.
No, not addition. What's the difference if you went from 70 points to 90 points? How much of a change is that?
20.
20. So what can you do with 70 and 90 to somehow get 20?
Exactly.
Subtract them. Very good. So that's what we need to do. We subtract them, okay, to find the change.
So that's 19.
Okay. Now, what's happening here? If it goes from negative 3 to 16, is that warming up or is it cooling off?
What code?
Negative 3 to positive 16.
Warming.
It's warming up. Okay? When we subtract these, okay, you always want to subtract the new temperature from the old. Okay, that's important. Just like on the test scores. If you had a 70 and then you got up to a 90, your new score is 90, your old score was 70. 90 minus 70 gives us 20. Okay? What's the new temperature? What temperature did we end up at? What's the new temperature?
16.
So we started at negative 3 and we went up to what temperature? This is the old temperature. This is what it started at. What did it go to? It went to 16. So I want to know what the difference is. 16 minus what's the old temperature? Negative 3. So, okay, what happens here? Becomes addition. Okay, what's 16 plus 3? 19. Okay, so there's an example using your subtraction. Okay, simple problem. Just find the difference in temperature. Okay, so the last two operations we're going to try to finish up with multiplication and division. Okay, so while Mr. Roy is writing down some rules for multiplication, does anybody know what do you get when you multiply? There's really four cases that Mr. Roy is going to write down. We have a positive times a positive. positive times a negative times a negative, and negative times positive, that's really the same as positive times negative. So it's really, I guess, 3. Okay. But let's start with the simplest one. What's a positive times a positive? Positive. Okay. What's a positive times a positive? Positive. Okay. How about if we have a positive times a negative?
That's a negative.
That's a negative. Okay. Positive times negative is negative. What's the last case?
Negative times negative.
Okay. A negative times a negative. Okay. What's that? What's a negative?
Positive.
Negative times negative is a
Positive.
positive. Negative times negative is a positive. Okay. So we're gonna write those rules down. We want you guys to try those 3 problems.
So guys, the same rules for multiplication, they go for division too, it's the same thing. Right, it doesn't change. That's why I put multiplied or divided by. And it's gotta put those brackets in there so you guys, so it doesn't all get jumbled into one thing.
Okay, let's start with A. Okay, first you have a positive times a negative. All I want to know is it positive or negative? Positive times a negative. Well, Brian? Positive times a negative is a negative. Yep. And it's negative, now we just have to do 9 times 8. Marcus?
72.
72. Next one is a negative times a negative. Okay. Negative times a negative. Yeah, Laura? It's a positive. And what is the answer? Positive? Positive 30. Okay. What about this last one? Okay, it's a positive times a positive, which is Isaiah?
That's a positive.
Positive. And we have something that's a fraction times something that's not a fraction. So what's the very first thing we have to do?
Oh, wait,
What?
you put a 1 underneath the 20.
We put a 1 underneath it. Okay, now when we multiply these together, you have 2 choices. You can either multiply it straight across the way it is right now and reduce it later, or you can reduce it first. How do people do it? Do you normally reduce now or you reduce later? Now? Okay, let's reduce it now.
Really?
So you look at the denominator here, that's a 4. You look at the numerator here, that's a 20. Is there a number that goes into 4 and 20? Nope, 5 doesn't go into 4. It does go into 20, but not 4. Is there a number that goes into...
I think I know what you were thinking.
You were thinking of the answer. But what number goes into 4 and 20? 2 does, yep. Anything a little bigger?
4.
1.
1 goes into everything, but what? 4. Okay. How many times does 4 go into 4? 4 goes into 4 once. 4 goes into 20 5 times. Right? Now we're going to multiply straight across. What's 3 times 5? 15. What's in the denominator? 1 times 1, which is what?
1.
Just a 1. Do we need to put it? No. Okay, any questions before we finish up with our last one? Okay, last one you guys are going to do is evaluate negative 5a cubed times b for those 2 values. Okay, finish up with that one. What's the first thing you have to do when you're going to evaluate? First thing.
Oh, figure out what it is.
Plug in. Plug in. What are we plugging in for A? Negative 2. What are we plugging in for B? Negative 4. Okay, when we do PEMDAS, What's the first thing we have to do here? Parentheses, and then we have that exponent. So what's negative 2? This is how you think of negative 2 cubed. What's negative 2 times negative 2? Positive 4.
16.
Negative 8.
And 4 times negative 2? Negative 8. Negative 5 times negative 8
Negative 4.
times negative 4. Let's start with negative 5 times negative 8. What's a negative times a negative? Positive 5 times 8? 40. And we have 40 times negative 4. What's a positive times a negative?
Negative.
Negative? What's 40 times 4? 160. Okay, when you guys come back, we're going to do division. Okay, we'll finish up with division. Okay, your homework tonight is page 84, really simple, 1 to 24.
Guys, make sure you write it down somewhere. If you're not sure, you don't get it, come see us, come up here tomorrow, we'll still be up on the board.
So 1 to 24, all.